Astro E2's primary instrument, the X-ray spectrometer, or XRS, is being built here at NASA's Goddard Space Flight Center.
XRS is primarily a spectrometer, and that is to say it looks at the spectrum of photons that come from a given source. The spectrum will tell you how hot it is, what it's made of, how fast it's moving. So, if you put light through a prism, you get a spectrum of colors. Same thing is true of X-rays. There's higher energy, shorter wavelength, and then there's lower energy, longer wavelength.
How can X-ray spectroscopy help us understand an X-ray source in space? Think about it like this.
So there is a stadium, and people are playing different games in it, and they're using different balls. And the guy or the woman is standing there outside, and then from time to time they get a ball. They look at the ball and they know what game is played. Spectroscopy is this, is the ability of telling what are the different phenomena that occur, say your stadium is like a black hole, or those, near a black hole. And let's say each phenomenon in physics is going to be a different game. And so you want to know what are the games that are played, so you want to get the balls, okay? So let's say you get a football and you say, okay, well, they're playing football. Well, you don't know where they're playing football. So now you need something which is like a good imaging, which is Chandra, for example. Chandra is going to tell you, oh, I know, because if I do an image of the stadium, I know where they're playing football. They're playing football right here, in that corner of the stadium.
The X-ray spectrometer is so sensitive that it can detect extremely subtle differences between individual X-ray photons.
If you play football like I do, which is a lot, I'm a pro, I'm a total pro. You can actually play football with ping pong ball if you don't know how to play football, but you also can play football with real football that you have burned so that they have a better grip. This is a trick for pro only. The game is really to have an instrument which is good enough to tell you the difference between the burned football, the non-burned football, and the ping pong ball. Astro E2 is going to tell you the difference between those three.
Work on Astro E2 is happening at the NASA Goddard Space Flight Center and in Japan simultaneously. This requires members of each team to travel between Japan and the United States to ensure that hardware and software components are compatible.
One of the things I really like about this project is working with the Japanese. There's some very hard-working people over there, and they're a lot of fun.
These trips also offer the chance to see old friends again. Yet, working with colleagues on the other side of the Earth can be challenging at times, especially when you have two very different cultures working together.
We have completely different cultures, customs, and systems, but we are working for the XRS on board Astro E2, and we have same goal.
Communication can be slow when dealing with a 13-hour time difference.
We do a lot of emailing. Of course, you can really get sort of one round of email per day because mostly they're asleep over there when you send it, and they answer it during the day and come back the next day.
Then there's the language barrier.
Our counterparts, almost all of them, speak English at some level, and that was really good for us because very few of us speak any Japanese.
When I was in the US, I learned a lot because they all speak English only. They don't speak Japanese, so I had to learn English.
Sampling the cuisine can be fun.
I really like sushi, and there's various other kinds of foods that I like a lot.
what surprised me most is that you Americans eat sweets at the end of lunch or dinner. That's very surprising for me. In Japan, I think sweets are for children or women, not for men.